Welcome to Chapter 3, Sensation and Perception. This is going to be the first video for this chapter, and it's going to introduce us to the topic. In terms of what is ahead in this unit, here we have a look at the layout, how we sense and perceive the world, the visual system, which will probably be the bulk of the unit in terms of days that we spend on it, the auditory system, hearing, and all the other senses. Okay, so let's just get right into it with that first topic, which is today's focus, how we sense and perceive the world, and really an introduction to the field and what it all means. First, let's start with when we perceive something, like you say you heard something or you saw something. You know, I saw my friend down the hall, or I tasted something and it was delicious. What sort of things go into that perception? It's not magic, and it's not, and it's, as you'll hopefully realize in this unit, it's not always correct. There's four main things that are going to influence our perception, and the first one is experience. If you have experience with a stimulus, it makes you more likely to be able to perceive it correctly. When you have expectations for a particular situation, that's going to affect your perception. You may expect to see something and then think you saw it or heard it or tasted it or whatever, and it may not be correct. So your expectations in a particular situation will affect your perception, and we're going to see how all of these specifically affect perception, but we're getting them out in the open first. Then attention. You have to be paying attention in order to perceive something. There's plenty of times, I'm sure you can think of examples, where someone was trying to get your attention and you absolutely did not hear them or notice them because you were not paying attention. You were probably, you might have been reading or doing something else. And then the context. The context affects our perceptions. Okay? So experience, expectations, attention, and context. Here's a little example of how weird perception can be. Now, take a look at those squares that have the letters A and B on them. You got this one A and that one B. Believe it or not, and I've done this and used this slide a million times, and it still tricks me, and it still seems impossible to me. But here's what the deal is. Both of those squares, this A here and this B, these squares are the exact same shade of gray. And I know they absolutely don't look like that to you. So these two are the same shade of gray, and I'll prove it to you. I'm going to take a little sample of A and slide it down and show you how it perfectly aligns with the B. And you can close your fingers around and follow the A, like make a little circle with your fingers so you don't see anything around it, and you'll prove to yourself that it did not change color. It's not me doing a trick. This is just a weird aspect of perception. So watch the A. It's going to slide down. Look at that. And it's the exact same color as the B. I'll do that again for you. And it's not changing color. That's about as close to magic as you'll get. What is an explanation for that? Probably because the B appears to be in the shadow of that green cylinder. So you assume that it's lighter in color, but in fact, it is the exact same color as that A. So we need to get some definitions cleared up, and let's start with the absolute most basic ones. We'll define sensation and perception here. Okay, this is really straightforward. Sensation is the physical part. It's the biological part. This is when your receptor cells are stimulated by the outside world and relay information to your brain. So that would be like you see something and these receptor cells in your eyes relay the information, or you smell something, or you feel rain hitting your body. This is biological, okay? Perception, on the other hand, is not the biological side. This is the psychological side. This is where the organism, because we're not the only ones who sense and perceive, the organism is going to interpret that sensory input. So the stimulus that you saw, the food that you tasted, the smell that you smelled, you're going to interpret that and give it meaning. What did I taste? What did it taste like? Who was that person? What were they wearing? And this is psychological, okay? Sensation is the physical, biological, and perception is the psychological or the mental. Related to that and overlapping are what psychologists refer to as the two levels of analysis. Two ways you can look at the same situation, and they're the bottom-up and the top-down types of analysis. The bottom-up analysis would be beginning at the level of the receptor and then working up. So what do we mean? So you would ask the question, looking at that flower, how are the colors and shapes combined to form the perception of a flower? That's from the bottom up. You're taking like the basic ingredients through your senses and then building them into, oh, it's a flower, that sort of thing. Which is quite different from the next one. The top-down analysis begins at the perceptual level, not the sensory level. And here, your past experiences will help you to identify a pattern. So take that same flower again, and your memory of flowers will help you recognize them more quickly. Think about like if a baby were looking, or a toddler were looking at a flower, they're learning what a flower is, they will look at it and they will probably in that case do like more of a bottom up to figure out what it is. But top down is when your past experience can help you. Something else that has been discovered over the years is our brains basically have special neurons that specifically will detect aspects of a stimulus. So feature detection is where your nervous system figures out what's important, quote unquote, as opposed to the stuff that's not important. So, when you're watching a movie on TV, you kind of block out the stuff around it and you realize that the TV is the thing that's an important thing. Or you're in class and you see your teacher standing up at the front. You're not hopefully distracted by everything else that's behind the teacher. You see that there's a human person standing there. All right. That's the important thing in that situation. Or you're talking to your friend. You're seeing your friend as the important thing, or you smell something, or you taste something, or you hear something. You hear particular words that you now know mean something, and you're not giving more importance to like the cars driving around outside, even though they might even be louder. Okay, so that's feature detection. And you actually have special neurons and sets of them that will identify the important stuff. So yet another magic thing that our neurons do. When it comes to the brain, these specialized cells that detect the world around us are called sensory receptors, and all of your sensory systems have them, whether it's vision, hearing, smell, taste, touch. These cells detect that information, the smell, what it looks like, the sound, and send it through special neurons, afferent neurons, or afferent nerves, which are collections of neurons, to the brain. Afferent neurons and afferent nerves go to the brain from the rest of the body. And you have these sensory receptors are how the brain experiences the world. So think about that. You have all these sensory receptors for all of your different senses throughout your body, your skin, your tongue, in your nose. They are the brain's way of getting the outside world into your mind. This little diagram just shows the different types of cells we have for the different senses. I'm not going to spend too much time on it. You can kind of look it over or pause on it if you want to. But I'm going to go over, there's some terms along the bottom here. Photoreception, mechanoreception, and chemoreception. So let's see what those mean. So photoreception this is only done by the eyes, and this is the detection of light. You have special cells in your eye on the retina that will detect light, and it's perceived, you perceive this as sight. All right, that's for the eyes. Mechanoreception, it has to do with mechanical, and this is actually a physical thing. It involves pressure or vibration or movement, and all of those three things can be found in your sense of touch, your sense of hearing, and your sense of equilibrium, which is like your kinesthetic and your vestibular system, which senses which come at the end of the chapter. And then finally, chemoreception, which is chemicals. This is the detection of chemical stimuli. And these are our sense of smell and our sense of taste. Those are also known as the so-called chemical senses, because the sensory receptors for taste and smell are detecting chemicals in the environment. Chemicals that land on your tongue, chemicals that go in your nose. That's how that's the way sensation happens. Couple of people you should know who were the early researchers in the field of sensation and perception. And these guys, the first couple guys, Gustav Fechner, he goes back to the days before psychology, before Wilhelm Wundt began studying psychology in a lab. Gustav Fechner studied sensation and perception in what was called psychophysics, and we'll see what that we're going to look at that term in a minute. Psychophysics was definitely one of the very popular early approaches in psychology, one of the top things that people researched in the late 1800s. And then we have Ernst Weber. He was also a German, lived also, through most of the 19th century, and he was a pioneer in what's known as experimental psychology, which is heavily into sensation and perception, and what's known as the JND, which stands for the just noticeable difference. All right, and we'll hear his name later because there is a law based on Ernst Weber. And two more modern people. One of them is actually still alive. He's 98 years old, and the other one died in 2013. But David Hubel, Canadian, and Torsten Wiesel, a Swedish neurophysiologist. They're both neurophysiologists, and they won the Nobel Prize in medicine for their discoveries in the visual system. So all these guys were very important in the study of sensation and perception. Now, I mentioned that term psychophysics a couple minutes ago. Let's just define that. It's kind of a weird word. Psychophysics is not like the theory of relativity done by a mental patient.
We all go a little mad sometimes.
Psychophysics, no. Psychophysics is the study between how physical stimuli like a smell or a visual stimulus or a sound, and how we experience them consciously or mentally. One of the common things that people studied early on was people's reaction time. How quickly could you respond when you saw a flashing light or you heard a sound, things like that. And in these early days of psychology and psychophysics, some important discoveries made about so-called thresholds. You may know of a threshold as that little strip of wood or plastic or rubber or metal that kind of goes between your door and the outside's kind of like separates one space from another. Well, the threshold separates essentially a stimulus from your being able to perceive it. So the absolute threshold for something is the minimum amount that you need to excite a perceptual system. What does that mean? So let's just use sound. The minimum amount of a sound, the softest it can be to excite or activate your auditory system. That would be the absolute threshold. So how soft can something be and have it still be detected? And absolute thresholds for humans exist for all the different senses. And we'll see what they are in a minute. And then there's a difference threshold. Remember that guy Weber? He studied the so-called just noticeable difference. The just noticeable difference is what's the degree of difference between two stimuli. So let's say you have two sounds. One is a little bit louder than the other. Well, what's the smallest amount louder it can be and still have you notice that it's louder, if that makes sense? Or it could be you get shown two lights of different brightnesses. What's the difference threshold or the just noticeable difference in brightness in terms of how like when you can say, oh, they are different? Weber's law is the principle that two stimuli, whether it's a sound or a taste or a smell, anything, has to differ by a constant minimum percentage. Like it has to be 20% or whatever it may be for you to perceive them as being different and not just the same. By the way, when you get your hearing tested, they are doing all kinds of this threshold stuff. You have to figure out, is this louder? Is this softer? Can I hear it? Can I not hear it? Okay. Let's a real quick look. I'm not going to spend much time on these, but these are the absolute thresholds, the absolute minimum amount that the human species needs to perceive at different sensory systems. So for vision, a candle from 30 miles at night. For hearing, it's the tick of a watch from 20 feet away. For the sense of taste, teaspoon of sugar in 2 gallons of water. For smell, it would be at 1 drop of perfume in a 3-room apartment. And for the sense of touch, I like this one, the wing of a bee falling on the cheek from 1 centimeter. All right, now here's something weird about psychology that it was much more popular in the 60s and 70s, and that is subliminal perception. Maybe you've heard of this, and it's closely related to thresholds. So what do we mean subliminal? Subliminal means the stimulus is below your absolute threshold, and you'll only be able to detect it less than 50% of the time. Half the time you won't, actually a little more than half the time you won't detect it. Sometimes you will. People used to put subliminal messages in stuff all the time, in like advertising, which is not surprising. The thought was like, if you put in a secret message that people won't notice but will affect their behavior, that was the thinking. Why would you do it if they don't notice? Because the idea was it'll affect their behavior and they won't even know about it. So there was this example from 1990 that was pretty well known at the time once it became noticed by people. All right, so Pepsi had these they were doing like limited edition cans for a little while that looked like neon signs. Here's what happened. So the cans had these kind of wild designs on them, and then someone noticed, if you stack these 2 cans up, look what it spells. Ooh. And that's That is usually what the subliminal advertising was kind of implying in all of their attempts to get people to part with their money. All right, and then one final thing for today's video, and that is signal detection theory. Signal is the stimulus that you're trying to detect. It is the theory that looks at how do we make decisions about a stimulus when we're not really certain what it is. So sometimes when you think you hear a knock at the door, but you're not sure, what goes into like you making the decision, yes, I did hear it, or no, I didn't? Well, your perception is going to depend on a few things. How intense is the stimulus? That might help you be able to detect it. How motivated are you? Are you trying to hear it, or are you like kind of spaced out? And what's the criteria set by the observer? Like, what counts as, oh, yes, I heard it, or no, I did not hear it, or see it, or taste it, or touch it, whatever. And the other thing is background noise. And that doesn't literally mean noise. It means other kind of distracting things. It could be sights. It could be other smells or tastes. It could be anything. But all of these things will impact on your ability to detect a stimulus. And that wraps up this quick little intro to sensation and perception. We will continue it at our first lesson in class. We will like kind of move on to some other stuff, and this will allow us to have more time next week on vision. All right, so thanks for checking this out, and we'll see you soon.